Hi guys, welcome to our channel Free Coding. In the previous video, we discussed about what variable is, so how you could name your variable. Also, we discussed about few basic data types in Python. Now in this video, we're going to discuss about data structures in Python, which is nothing but again few other data types that are non-primitive here. All right, so let's get started here. And like I said in the previous video, data is the most important thing based on which your source code is gonna be on, or based on which you're gonna build your project. So such data has to be stored in a proper manner, should be structured properly, right? You have to store it, you have to structure it, you have to organize it, make sure it's manageable. You should also manage your data. And data structure is the way of performing or structuring your data in a programming language. So like how much your data is important, data structure is also that much important. It is going to structure your data, right? So data structures is the fundamentals of any programming language that you go for. And Python provides you a simpler way of understanding these data structures here. And data structures are of two different types here. One is primitive and other one is non-primitive, as you can see in the picture. And primitive is nothing but the one that we saw in the previous session. The integer, float, complex, string, boolean, all these comes under primitive data structure. Whereas non-primitive are again further divided into built-in and user-defined. So built-in has list, tuple, set, and dictionary. You also have something called user-defined, under which you have queue, stack, linked list, graph, and hash map. And all these are requires three things, or there are three things that you could perform on all these data types. One is you could create them. The other one is you could assign values to them, you could change the values on them, and finally you could perform operations on the data that are being stored under these data types. Now for this session, we're going to stick with the non-primitive built-in data types, which is nothing but list, tuple, set, and dictionary. So let's go in detail about what list, tuple, set, and dictionary are. So starting off with list is nothing but, it's also called as a large variable. So where you could store a lot of data, you could store, multiple data here. So it could be also, it's simply called as an ordered collection of data, which ordered collection in the sense, it has a collection of data, collection of elements or collection of items, and it's going to be in an ordered format. And yeah, you could just name it just like how you name your variable. You should follow all the naming conventions. It's also a variable here, but it's a different kind of data type. It's a list data type. That's it. So just make sure you name it properly, just like how you name a variable. And it could store different kinds of data. That's the major difference between having a list and an array. In array you can't store different kinds of data in it, but inside a list you could store different kinds of data. And how would your interpreter gonna identify whether it is a list or not is by looking at the brackets. If all your elements or items are enclosed by using a set of square brackets, then that's how your interpreter is gonna identify that this is a list. And repetition is nothing but you could have repeated items inside a list. So for example, you could have multiple item 1 in your list, so that's possible. And this is the major thing here, indexing, and most common thing that most beginners would make a mistake here. Indexing is nothing but, say if you're storing a particular data called 10 under a variable called x equals 10, then which means whenever I want to access 10, I have to use the variable x. But here in list, I'm going to name the list as list1 and store multiple data under it. Now if I want to access a particular data, how am I gonna differentiate it between that particular data and the remaining data? And that's where the indexing concept comes in. You have something called index numbers here, which would start at 0 and go in the increasing sequential order, 0, 1, 2, and 3. And using the index number, you will have to access the data. For example, if your list has 4 items, the index value of first item would be 0, second would be 1, third would be 2, and fourth would be 3. That's what index is. And yes, this is also quite an important one. It's mutable. Mutable in the sense, you could perform different actions in it, like you could add an item wherever you want, you could insert an item, you could remove an item, you could delete the list. It is mutable, it is completely flexible, and list is the most flexible built-in non-primitive data structure that you have in here. And you could perform concatenation. Concatenation is nothing but combining list together to to create another list is what concatenation is. And all these data types, like list, tuple, set, seek, free dictionary, all these would come under common data type called sequence data type. Technically, they're not all sequence. Only list and tuple would come under sequence data type, and string would also come under sequence data type. But you could also use dictionary and set as a sequence one, just like how you use your list and tuple. I'll take you through an example. And here is an example. So you have two kinds of list here, list 1 and list 2. In list 1, you have different kinds of data, hello, 12, and true. So it's a list because it's enclosed by a square bracket. And list 2 is also considered as a list. Yeah, just one item is being stored enclosed by a square bracket. And make sure you separate all the items by using a comma. So hello, comma, 12, comma, true. Now moving ahead with the next data type, which is nothing but tuple data type. Tuple also is one of the sequence data type that we have in here. And there are a lot of differences between list and tuple. First of all, the common thing is it's also an ordered collection of data, which means it is ordered. It can have different kinds of data in it. And you can just name it just like how you name a variable. And yeah, just like I said, you can have different kinds of data under tuple. Now, this is how your interpreter is gonna differentiate between the list and a tuple. If all the data or items are enclosed by a set of parentheses, then that's how it's gonna find out that this is a tuple, and that's what gonna make the difference here. And it could have repeated items. It could use indexing numbers here. You should have to depend on index numbers in order to access a single item from a tuple. And it's immutable. This is another difference. When it is enclosed by a set of parentheses, then it becomes immutable. It's a tuple, it's an immutable one. You never get to add data to a tuple. You cannot, remove items from a tuple and all. And concatenation is possible. You get to combine tuples together. That's how you could actually add data to a tuple, but it's not a flexible one. It's completely immutable. And here is an example. You have two examples. One is tuple 1, other one is tuple 2. In tuple 1, yeah, you have hello, 12, and true. The interpreter is going to identify this as a tuple, not by looking at the variable name, by looking at the brackets it has. It's a parenthesis, so it's a tuple. And tuple 2 equals to hello, but like we saw in the previous example, if you want to store only one item inside a list, that's possible. You could just use a set of square brackets and an item inside it. But when it comes to a tuple, if you're if you're storing only one item inside a tuple, you have to make sure it is you're using a comma after the first item, just like how I did it in here. After hello, I've added a comma. Or else, if not, it would read it as a string. I'll also take you through an example how it is going to read it as a string or an integer. The next data structure, the data type that we have in the line is set. So set can have different kinds of data. It is not an ordered one here. So you don't have something called indexing here. You never get to access a particular item. You never get to add the item where you want. You never get to remove an item. You get to remove an item, but you never get to add a particular item where you want. You never get to access an item. It gives items in a random order. So just name it like how you name a variable. And this is how your interpreter is going to find out that this is a set by using or by looking at the curly brackets. If all your items are enclosed by a set of curly brackets, then that is a set. And this is another major difference between set and list tuple. Here, you cannot have repeated values. Repeated values will be automatically eliminated by the interpreter when it is inside a set. It has to have unique values. And it is mutable, but it's not as flexible as list, but still you can add items, you can remove items. Yeah, here is an example. So set 1 equals to hello, comma 12, comma true. So you have curly brackets. If I want to access 12, that's not possible. You can just print set 1. It would just print all the items in a random order, but it stores it in the variable in a different format. I'm going to explain that with an example. Next is dictionary. This comes under mapping data type. This is a lot different from other data types that we have. And why do we have dictionary is because, say, for example, I want to store a lot of information about an object. Like, for example, I want to store about a particular student's name, age, is all the subjects score, different information about that particular student. In such cases, what you could do is you could use dictionary. You could also use list and tuple, would obviously work. But the problem with list and tuple is you have to depend on index numbers to access an item. And it's, of course, if your number of items in the list is less, it's fine to use an index number to access an item. But what if you're going to store like more than 10, 20 items? Then you'll have to count every time to find out what index number this particular item has. In order to avoid that, you could use dictionary. And how this dictionary is going to make it a lot easier is by using something called key value pair. Till now, whatever we saw, every data type had only the values, but this dictionary is going to have something called key for each and every value. And if you want to access the value, you could just use the key here. You don't have to go with the index number. And together it is called as an item. And if you're enclosing it with a curly bracket, it's a dictionary again. And again, we are going to use curly brackets for set as well. Now, how would the interpreter make the difference between set and dictionary is, if you have a key value pair, if key and value are separated by a colon, then that's a dictionary, or else it's a set. And it's an ordered one, together as an item, it would follow an index number. But if you use an index number, it would not return the item. You have to use the key. Access value through keys. Just like I said, you have to use keys to access the values. And the keys and values, you have to, approach them differently. Keys are immutable. It has to be unique, because you're going to use keys to access the value. What if this different values have the same key? Then what value would the interpreter return? So that's not possible. Your keys has to be unique, and you can never change the key. You could delete the entire item along with the key, but you could never modify it. And talking about the values can be repeatable and it is mutable. You get to change your values as you want. So here is an example. This is how you define a dictionary. Make sure you enclose entire set of items within a set of curly brackets. And as you can see, name is the key. Anything that is on the left-hand side of the colon is called as a key. And the one that is on the right-hand side would be considered as a value. So if you want to access John, you could just use the key called name. And if you want to access his age, you could just use the key age. If you want to access his ID, use the key ID. And separate each and every item by using a comma. Now, I'm gonna, we have seen a lot of theory part, right? Let's take few examples in order to get a better understanding in all these 4 data types. Right. So here are a few examples. I'm not gonna go in detail in them, but now I'm just gonna give you certain examples that that you could used to understand how you define a list, set, dictionary, and tuple. And there are certain other, in the future, I'll be posting more videos on how you could use multiple functions in order to, manipulate these data structures or these data types. Now, starting off with our first example, again, guys, this is Jupyter Notebook. You have a run button here. You have different cells. In order to run it, just click on a cell, click on the run button, and see your output right below your cell. So this is cell 1. I have an empty list. So this is how you create an empty list. This is how the interpreter understands that this is an empty list by using a set of empty brackets, square brackets. And type of list 1 would written what kind of data type this list 1 is. So since it has a square bracket, it would be considered as a list. So there you go, list. And the next cell you have, I do have a list called list 1, and I have multiple items, guys. List 1 equals to 1, 2, 3, 4, 5, 6, and 4, which means the value is being repeated. And then I'm having another list inside it. So that is possible. You could have a tuple inside a list. You could have a list inside a list. You could also have a dictionary inside a list. And so this is another thing that I want to show you. Print of len of list 1. So len is nothing but the number length, the function length. It would tell you the length of your list 1 is, which means number of items your list 1 has. So in total, it has 8 items. So 1, 2, 3, 4, 5, 6, and 4, 7. Plus, there is another list here, which would be considered as the next item altogether. So that would be 8. So it's going to print 8 for this, and it's going to print list 1 of 0. That would be 1, the first item. So 8 is for the print output of print, and 1 is nothing but the first item, the index 0. So whenever you want to access an item from the list, make sure you're writing the index number within a set of square bracket. Everywhere, wherever you use your index number, other than 1 or 2 places, you have to make sure the index numbers are within a set of square brackets. And you have len of list 1, so that would be 8. So I've just shown that earlier. I also want to show you something different here. I don't know if I've added that. Okay. There is another way of using an index number, which is nothing but the reverse direction. So list 1 of -1. So when I say -1, the last item would be -1. So you could go in the index number either in the forward direction or in the reverse direction. So when you go in the forward direction, your index number starts at 0 and goes in the increasing order by 1. But if you go in the reverse direction, it would start at -1 and goes in that direction, -1, -2, -3. So now when I say -1, it would print the last item, which is nothing but 12, 3, and 1. So there you go. So this is another way of, using your index number. So if I go for -2, then that would be 4. So you could just go in that order. And if you try to go beyond the number that isn't available, that would probably throw an error saying, index error. So -1, 8 is possible, -9. So index error, which means your index is out of the range. So there is no item called -9 there. So this index value item 1 has the index number -8. So after 1, there are no more items on the left-hand side. So this is concatenation, guys. So I have list 1 and list 2, combining list 1 and list 2 together. So that would, what happened? Name error, L3 not defined, my bad. So I'm gonna change the name. Okay, so list 3 equals to list 1 plus list 2. It's not gonna perform addition operation here. It is just gonna combine it. But if it is an array, what it would do is it would perform the addition operation there. But that is not possible when it comes to list. That's another difference between list and an array. So you have 1, 2, 3, 4, 5, 6. So all would get combined under a single list, which is list 3. and list 4 has a single item. So yeah, if you want to store a single item under a list, that's possible. And type of list 4 would still be list, and list 4 of 0 would be the item that you have. The type is list, and list 4 of 0 would be 12, the first item. But when it comes to tuple, that is not the case, guys. Keep that in mind. I'm going to show you an example in some time. And this is an empty tuple. You have to just have an empty set of parentheses, and type of tuple 1 would be still tuple. And this is tuple 1. 1 comma 2 comma 3 enclosed by a set of parentheses, and that's how your interpreter is identifying that's a tuple. And yeah, index number works just like how it works with Python, works with list. So when I say tuple 1 of 2, then that would be 0, 1, 2, which is 3. 2 here is the index number, so 0, 1, and 2. And tuple 2 of 1 would be, I'm sorry. So this is another tuple, which is tuple 2, and I'm assigning a data called 1 inside it. So here I'm just storing only one item inside a set of parentheses. Let's see how the interpreter is reading it. Is it going to read it as a tuple, or is it going to read it as an integer here? So type of tuple 2, let me run it. So there you go. It's not reading it as a tuple. That's what I said. When you are enclosing a single data within a set of parentheses, it would read it as the data, it would return it as a type of the data that is stored inside the set of square brackets, or sorry, set of parentheses, not as a tuple. So if you want your interpreter to read it as a tuple, make sure you add a comma after your data, just like how it is in cell 11. Now it is reading it as a tuple. So type would let you know what kind of data this particular data type or the variable is storing. So concatenation is possible. Tuple 3 equals to tuple 1 plus tuple 2. 1, comma 2, comma 3, comma 1. Here again, it means your list and tuple can have repeated values. Now jumping to set. Guys, till now we were seeing how to create an empty tuple and empty list, right? Because you could just use this empty brackets that belongs to that particular data type. If it's a list, use a set of empty square bracket. If it is a tuple, use a set of empty parentheses. But when it comes to set, you have to use the keyword set, because set and dictionary both have same set of brackets. They both use curly brackets. So if you write an empty set of curly brackets, it would be considered as an empty dictionary, not as a set. So in order to keep it different, you have to use the keyword set and a set of parentheses here. So that would be type of set 1 would be set. And look here, guys, in this example, I've created a set enclosing it by a set of curly brackets 1, 2, 4, 14, comma 2, which means I'm repeating the same value here and gonna run it. See, type of set 1 is set, and print set 1. 1, 2, 4, and 14. It did not print 2, which means it has eliminated the repeated values. So that's the major difference here. And yeah, okay, with this example, you get to understand how your, Python is, how Python is storing the set value inside the set variable. So in Jupyter Notebook, why I said Jupyter Notebook is an easier one is the best one for a beginner, is because you get to see how the data is being stored inside a variable here by just writing the variable name. This is not available in many IDEs. So there you go. So set 2 equals to, you have a set here, 1, 23, 4, 14, 2, and 15. Now, if I run this, and this line is gonna print whatever data is being stored under the variable set2 in whatever format it is storing. Now, if I run it, you could see that the order has changed now. After 1, I had 23, but it has changed the order in here. So it is storing it in an ascending order, guys, when it comes to integers. Got it? But when you say, let me add another line. So when I say print of set true. It would just print it in a random order, guys. All right, that's the difference. And here, this is another major information that we need to know. Set 4, again, set can have different kinds of data. So set 4 has numbers, integers, a Boolean data type, a string, a tuple, and again different strings, lowercase a and b, uppercase a. And when I print that set 4, it would print just it in a random order, guys. No, there is no proper explanation for this. It is just printing it in a random order. But if I want to see how it is being stored inside set 4, there is an order here when you have different kinds of data. First of all, your set cannot store a list or a dictionary inside it. It could store a tuple, integers, numbers, decimal numbers, strings, or Boolean data type, but never list and dictionary. That's one thing. And second thing is the order that it is gonna store when it has different kinds of data. So it's always tuple first, followed by that you have your numbers. So it's a combination of integers and decimals. And then you have your, excuse me, you have your a string alphabet, in the alphabetical order, the uppercase strings, and then your Boolean, and then comes your lowercase string. So this is the order you need to follow, guys. So if I run it, you could see it's the tuple. First of all, no matter what data this tuple has, it's always the tuple in the beginning, and then followed by that you have your numbers, and then uppercase letters, your Boolean, and you have your string data type. Now, moving ahead with the final data type that we have, which is dictionary. So when you want to create an empty dictionary, you have to use an empty set of curly brackets, and type of dict1 would be dict. And yeah, here you go. So this is a simpler way of creating a dictionary. Make sure you're, writing it in a proper order. And this is the only place, I guess, you will be using a set of curly brackets, guys. So you have name as a key, John as a value, and age as a key, 14 as a value, score key. The key value for score is 45. Value for active is true. So here, on the key part, we have strings, but that's not the case. You could have, your numbers. Your key could also be a Boolean data type or a floating data type. Anything would work, guys. And you could also have another list and tuple here, and make sure you separate each and every item by using comma, and key and value should be separated by a colon, and key value together, it is called as an item here. So let me define it. Now, if I want to access a value called true, I have to make sure I use the keyword active. So dict1 of active. If you've seen in tuple and list, we use the index numbers there, but that's not the case here, guys. You have to use the keys. So dict of active would be true, and you should make sure you're writing it with the quotation. If it's a string, no matter what, if it's a string, you have to use it with a quotation. And I have, two keys here. First active is true, second active is false. Now what would happen is your interpreter would replace the previous value, because true, this is the line the interpreter would be reading first before reading this line, right? So this value would get replaced with the new value. Now if I run it, you would not be having true, you would only be having false. So you cannot have the repeated keys. It would just eliminate the old one. So this is just a basic intro, guys. I'll also be taking you through different methods that you could use on list, tuple, set, and dictionary, which we will be seeing soon. And until then, bye, see you, take care.